So today, the chain rule. So here are four derivatives that you already know how to do. And then I'm going to look at a related derivative. So first of all, what the pattern is here is there are two different functions, x squared and sine of x. So there are four different obvious ways to combine x squared and sine of x to get another function. I can multiply x squared times sine of x, I can add x squared and sine of x, I can divide x squared and sine of x, and I can subtract x squared of sine of x. So you should start by pausing and finding out what those four derivatives are using the rules you already know. All right, so the first one, we're going to use product rule. So we're going to do f prime g plus f g prime. So the derivative of x squared sine x equals f prime is going to be 2x, g is going to be sine x, plus f, which is x squared, times g prime, which is cosine x, all right? So that's using the product rule because it's a product. When you have a sum, you can just do the two derivatives separately. So the derivative of x squared plus sine x is just 2x plus cosine x. All right, different rules for different operations. All right, we have this one is a quotient. So this is f on top, this is g on the bottom. Let's make a note, let's make a little chart, I guess I should say, of f prime and g prime. Right, we've probably done some of these for practice already. So we're going to do f prime g minus f g prime over g squared. So that's going to be 2x sine x minus f g prime is x squared cosine x over g squared, which is sine squared x. And there's no way to simplify that, so we just leave it like that. All right. If we have a difference, that's the same domain as subtraction. We can just distribute and we can do it, we say term-wise. So this derivative is just 2x minus cosine x, all right? Four different ways to combine the two functions, four different ways to find the derivatives. Now, here's the other way you can combine x squared and sine x. What if I had sine of x squared? All right, this is called composition. All right, so if sine of x, so let's say we say f of x is sine of x and g of x is cosine of x, oh, sorry, g of x is x squared, then what we're looking at, the composition we're looking at here is f of g. All right, hopefully you've seen that notation, f of g. All right, so what if I want to know the derivative of sine of x squared? Well, none of these rules apply. So what rule does apply? So you have a rule that deals with compositions under your book, section 3.6, the derivative of a composite function, so that's a composition, all right? And here it is, it's called the chain rule. All right, so you know it's like laid out okay here. In the product and quotient rule, I gave you the proof. An airtight proof of the chain rule can be constructed through a different approach, but we will omit it here. They give sort of a tempting proof that then they explain doesn't really work. So an airtight proof, which we would just call it a proof. This is not a proof. A proof of the chain rule, we'll omit it. Like they don't even put it in a appendix. It's like we're just not even going to bother. And you know what? I'm not either going to bother. We're going to just let this rule be, and you'll prove it if you do take an advanced calculus course. So this is one that we're going to take on faith, and it goes like this. And you know, a lot of these things you'll see how they're borne out by experience. F of g of x prime is equal to f prime of g of x times g prime of x. What? What does that mean? Well, I'll show you. And it's also, it's sort of easier to explain verbally. So I'll try to add that in, but we want to find the derivative of sine of x squared, right? So the first thing we're going to do is f prime of g. So like the key is to see that there is an inside function and an outside function. An inside function and an outside function. All right, that's what you got to be looking for. There's a function is put inside another. There's an inside function and an outside function. So the first thing you're to do is take the derivative of the outside function, but the inside function stays the same. So we're going to do the derivative of sine is cosine, but the inside function is going to stay the same. So here's derivative of the outside function, but the inside function stays the same. And then you multiply times the derivative of the inside function. Well, the derivative of the inside function is 2x. So you're basically going to multiply by g prime, and I'm always going to neurotically draw that little arrow right there. So that gives a way to say in words what's going on here, is that we're doing the derivative of the outside while keeping the inside the same, and then times the derivative of the inside. All right, now I'm saying that now, but the more like we practice and do some of these, the more you'll see it, what that means. So here's, right, remember your colossal compendium. So in the back, here's the chain rule written out nicely. Here's the verbal description. Derivative of the outside, keep the inside the same, times the derivative of the inside. Okay, let's do some more examples and see what that means. We're just gonna start jump into the homework. This is one of these things that's like easy to explain what the rule is, and then it just takes a lot of work and practice to get how it actually falls out. So yeah, I think I'm going to start with not any of these examples because they're a little out there. But let me just give you another example. So let's say I had like e to the 5x squared plus 3, okay? So what would I do? I would do the derivative of the outside function. Well, the outside function here is e to the x. So I'm going to do the derivative of the outside, keeping the inside the same, right? So I did, let's find my nice green color. Did the derivative of the outside, kept the inside the same. And then I just multiply times the derivative of the inside. Well, the derivative of the inside is 10x. So it's times 10x. And that's your answer. Let's make that black, times 10x, right? What if I had cosine of 7x squared minus 12, all right? Derivative of the outside, negative sine. Keep the inside the same on the first step. Then multiply times the derivative of the inside. And that's it. And a lot of times these won't simplify very well, right? So we did the derivative of the outside, keep the inside the same, and multiply by the derivative of the inside function. So you try a couple of these. Let's do tangent of ln of x. Let's do sine cubed x, which, just to remind you, so you can see the inside and outside function, that means sine of x cubed. So sine is your inside, cubed is your outside. Ln of x to the 5th power. And I'm just making these up. I don't know if you can tell. We will do secant of x squared. All right, there you go. You try these 1, 2, 3, 4 on your own, and then I'll give those in the next video, and then we'll try some homework problems.